Everyone, my name is Yogesh from Shri Venkateswara College of Engineering, EC Department, 5th semester. Now I am going to explain a data flow diagram of ARM processor. Introduction to ARM processor. Architecture. ARM, Advanced RISC Machines. Processors are a family of reduced instructions set computing RISC architectures used in a wide range of applications from mobile devices to supercomputers. The architecture is designed to be energy efficient, make it ideal for portable devices with limited power resources. ARM processors are known for their simplicity, low power consumption, and high performance. Key features. Thumb to instruction set allows for both 16-bit and 32-bit instructions, improving code density and performance. Press-down technology provide hardware-based security features to protect sensitive data and applications. Neon SIMD, which means single instruction multiple data engine, accelerates multimedia and signal processing tasks by performing multiple operations in parallel. Overview of the data flow in ARM processor. First it is fetch, then it is decode, execute, memory access, and write back. Fetch means during the fetch stage, the ARM processor retrieves the next instruction from memory. During decode stage, in the decode stage, the ARM processor decodes the fetched instruction and determines the operation to be performed. After decode stage, there is an execute stage. During the execute stage, the ARM processor performs the operation specified by the decoded instruction. After execute stage, there is memory access. In memory access stage, the ARM processor accesses memory if required by the executed instructions. After memory access, there is write back. During the write back stage, the ARM processor writes the result of the executed instructions back to the appropriate register or memory locations. Next, the fetch stage. The fetch stage is first stage of the ARM processor where instructions are fetched from memory and prepared for execution. Steps involved in fetch stage. Program counter EC is incremented to point to the next instruction address. The instruction address is sent to the memory management unit MMU to translate the virtual address to a physical address. The physical address is sent to the memory unit to fetch instruction from memory. The fetched instruction is stored in the instruction register IR for decoding and execution. Decode stage. The decode stage of the ARM processor is responsible for decoding instructions and preparing them for execution. This stage follows the fetch stage and precedes the executed stage. The decode stage involves the following steps. Decode the instruction. The instruction fetched from the memory is decoded to determine the operation to be performed and operands involved. Register file access. The decode stage accesses the register file to read the values of the register that are used as operands in the instruction. Operand preparation. The decode stage prepares the operands for the execution stage by performing any necessary data conversions or calculations. The branch calculation. If the instruction is a branch instruction, the decode stage calculates the branch target address based on the branch offset and the current program counter. Control signal. The decode stage generates control signal that specify the operation to be performed, the executed stage, and control data flow with the processor. Next, execute stage. Execute stage of the ARM processor is responsible for executing instructions and performing calculations. It involves the following steps. Fetch instructions. In fetch instruction, in this step, the processor fetches the instruction from memory. The next step is decode instruction. The decode instruction, the fetched instruction is decoded to determine the operation to be performed. After the decode instruction, there is perform calculations. The perform calculation step, the processor performs the necessary calculation based on the decoded instructions. Next is store results. Store result. The result of the calculation is stored in appropriate to register or memory location. Next, memory stage. The memory stage of the ARM processor involves accessing and manipulating memory. This stage is an essential part of the processor's operation as it allows data to be stored, retrieved, or modified in memory. Fetch data, store data, and modified data. In fetch data stage, The processor fetches data from the memory. This data can be instructions or operands needed for the execution of the program. The next stage is store data. The processor can also store data in memory. This is useful for saving intermediate results or storing data for later use. The next stage is modify data. The modified data, the memory stage allows for the modification of data in memory. This can involve performing arithmetic or logical operations of the data. Write back stage. The write back stage is the final stage in the ARM's processor's pipeline. In this stage, the results of the executed instructions are returned back to the memory or registers. The first step is write results to memory. In write results to memory, if the instructions has modified memory, the results were written back to the appropriate memory location. Write results to registers. Write results to registers. If the instruction has modified register, the results return back to the appropriate registers. Conclusion. Clarity in data movement. The DFD provides a clear visualization of how data flow within the ARM processor architecture works. This elucidates the pathways through which information travel, facilitating a comprehensive understanding of the system operations. Next, identification of components. By delineating the distinct components and process within the ARM processor, the DFD aids in identifying key elements contributing to its functionality. This segment allows for targeted analysis and optimization of individual components. Insight into interactions. Through the depiction of data interaction, the DFD eliminates the interdependencies among various components. Understanding these interactions is crucial for ensuring seamless communication and coordination within the processor. Thank you everyone. Please watch and like my channel.